Okay, we continue. Sorry about the technical error. Okay, we continue the this week with the next chapter, diagnostic testing in high voltage. As I explained before, okay, we now come to a section in which we're going to learn or to go into further details of on the procedure or how we perform the experiment or high voltage experiment in the lab. Okay, what are types of testing and testing that been conducted in the lab, the circuit arrangement, what is the purpose of doing the testing, etc. in the high voltage lab. Okay, so okay, there are in the high voltage field. There are actually two type of major testing technique or procedure. One we call it destructive testing procedure, and then the other one is non-destructive testing technique. Okay, so one is destructive and the other one is non-destructive. Okay, by looking at the title itself, we know what is destructive and what is non-destructive, in which we classify into these two main category. And for destructive testing procedure, that will involve the testing on the specimen that will somehow will destroy or deteriorate the functionality of the sample itself. Okay, normally after the testing we cannot use the sample that been tested. Okay, this is because sample that been tested is the sample that been tested is already destroyed. I mean the original characteristic has been distorted, and then it cannot be longer be used for subsequent testing procedure. Okay, normally the equipment destructive cannot be used in the service, and it is primarily to test whether the device or the testing specimen is able to withstand the normal and abnormal voltage conditions. So means that we have the sample, say insulators, we apply the destructive test to see whether the sample or the insulator that we fabricate, the one that we manufactured, are able to sustain with the nominal voltage or the over voltage level. So we apply very high voltage with the intention hopefully to destroy it, but at some point we try to see whether the sample that we place in the testing work fine as what we expected. Okay, on the other hand, that on the non-destructive technique, for this one we know the sample can be used and reused again and again. We test the specimen under certain conditions, and then after the experiment we can actually use the same sample for other experiment, because the testing not destroy the original characteristic, not destroy the functionality of the sample. And then of course if since it is not non-destructive, the functionality there will be no deteriorations of the properties. Okay, for destructive test, okay, for the destructive test, I will explain to you four example of destructive test procedure, in which we will see salt fog test, tracking test, HVAC test, switching and lightning impulse test. Okay, we will look at these four tests in terms of arrangement, the purpose and the functionality. Okay, okay, salt fork test. Okay, what is salt fork test? Why we call it salt fork test? Anyone? Why? Why we call it salt fork test? This one is actually accelerated aging testing. We try to replicate. Normally, this one, the salt fork test is to replicate the scenario in the under environmental polluted conditions. That is one, and the other one is ocean, by the beach, coastal area, in which the humidity of the air is greatly affected by the salt. Okay, and the salt also to replicate the pollutions or the water layer on the insulated surface to be under conductive. Means that we will conduct the salt fork test to represent the scenario that happen in real life. Okay, and then okay, this is the arrangement. If you can see here, okay, what we have, for the test fork test procedure in the lab. First, what we have is actually the chamber. We should have a chamber. It is depend to the sample size. It can be one cubic foot, or it can be 1 meter 1 meter cubic, or it can be bigger than that. Okay, it depends to the sample. What we have, this will be the chamber, and then within the chamber we will have a nozzle. Okay, these are the nozzle. Okay, what the nozzle did is actually it will spray the sample with the spray of the fog, so that we can replicate the sample under fogging conditions in the morning, under light rain conditions, to replicate, to reproduce what we found in practice. Okay, this is the sample. In case the sample is insulator, we will place it the insulator, in which the insulator will be, the sample will be connected to the high voltage end and low voltage end. So once connected to the high voltage end, and the other one to be connected to the ground. While running the experiment, the fogging, the spray, actually this one is available in the standard. There are certain procedure and criteria that need to be complied, and even the salt fog environments, salt fog spray, they have a certain characteristic. Means that maybe the requirement will be like 10 millimeter per the spray rate value will be like 10 millimeter per hour, very slow, for example. Okay, so of course this one connected to a salt water tank, and we have a pump here, pump to pump out the salt fog through the nozzle, and then we have a air compressor, so that we can have the water droplet to become a fogging, a very tiny water drop, to reproduce as a salt fog. And then what's next? We connected the measurements, the sample with the shunt resistor, as what we learned in the previous measurement technique. In this case, it is 1 mega ohms to be the shunt resistor, and then we connected to also the current measurement resistor, in which we try to capture the current value, and then this will goes to the data acquisition system, and we can actually monitor by using a computer to capture the data by using the computer. Obviously, the high voltage terminal is connected to the transformer. The high voltage point will be connected to the transformer, so that high voltage can be generated at the sample. So all what we did is actually we run the salt fork so that this chamber is filled with the forks, and then we place the sample which been connected to the transformers, and then we just monitor the data measurement of this system by using data acquisitions, something like LabVIEW software to monitor and to record the data. Okay, so by doing this test, we know that there will be no leakage current, there will be no spark under dry conditions. That's why in this case we make the condition, the environment to be under fogging condition, because of fogging the humidity is very high, and with the humidity once we have under salty condition, that one will be kind of conductive, that can easily trigger for the flashover. Okay, this is the schematic diagram. Okay, this is the schematic. Okay, make sure you know what is schematic, what is block diagram, what is the circuit representation. You should be able to differentiate. If been requested or if been asked, can you draw a block diagram of blah blah blah? This can be a block diagram. A schematic diagram is just pretty much similar. And then circuit diagram may not necessarily like this. It's just a connection of wire. This one is we can have in terms of the block diagram. That is also the way we represent the laboratory measurements. Okay, this is the real photo at the Manchester University. Okay, in this case we have the sample. Okay, this is how we perform the experiment. We have the sample, and then this sample is connected to the ground, and the other one is connected to the high voltage. Okay, what is high voltage? They just use a conductor here, and then come to the shunt resistor. Now we have voltage divider here. Very high voltage, we have voltage divider, so that we should be able to measure the measure voltage and current values. So we suspend this one on this point, and then we spray the chamber, this one, with the salt water. Okay, I don't need to repeat this. You can read by yourself. So at least you should know working principle of salt fork test. What are the circuit arrangement? How they have been connected to one and another. Okay, what we need is the chamber. We need the compressor. We need the water pump. We need the high voltage resistor. Very high values. We need the transformers. And of course power supply. Right, and then okay, the high voltage was supplied to the conductor from this is just the arrangement. Okay, while we inject the high voltage to this point, okay, while we inject this high voltage to this point, there will be because this is the insulator, and with the presence of the humidity, the conductive humidity, which is the salty fogs, we expect there will be a leakage current. We interested with the leakage current on the surface of the insulator. I mean, technically, the conductor shouldn't conduct current. So we should measure zero current. Okay, but under humidity conditions, there will be a conduction on the surface of the insulators. That is allowed us to study on in terms of the performance, right? And okay, the test may be conducted at specified working hours. For example, 1,000 hours or maybe 100 hours consecutively. So at the end of the test, we will take out the sample. We will see whether the silicon rubber are able to absorb the pressure, absorb the electric field or discharge activity on the due to the humidity. Okay, we have okay, I don't need to read this because they are actually just what I just explained to you. So make sure you know what is salt fog test, what is that for, why we need to conduct salt fog test, and then maybe you should be able to sketch a simple, not necessarily to be this one, but you can come up on your own with your own understanding. Obviously this one is correct, but you can have your own version, no problem, because what we need is actually for the student to understand the principle, how it's work. Okay, the salt fog test, why we interested to perform this experiment. And maybe you need to know the circuit arrangement and how we going to perform the test. Okay, the second one we call it tracking test. Okay, why tracking? Why we call it tracking? Because normally this one tracking test is performed on the insulations. Again, insulations, polymeric insulators. For example, porcelain insulators. Why we call it tracking? Okay, because for the power system and high voltage applications, especially for the insulators, these high voltage insulators, due to the very high voltage being applied to the high voltage terminal constantly 24/7, so this insulator will be subjected to the aging, penuaan, the kerosakan, deteriorations of the functionality, etc. So for the tracking, we going to study whether the sample of the insulator able to sustain with the very high voltage applied to the high voltage terminal, so that we can check in terms of the performance. Tracking is actually the formation of surface deteriorations due to electrical discharge. Okay, you used to see electrical discharge as simple as from your plug at home. From the discharge, you can see when it occurred constantly at a very high magnetic value, the silicon rubber or the insulator somehow will be greatly affected by this discharge activity. That will lead to the procedure, the phenomena known as tracking. Tracking means that the discharge leave a mark on the surface of insulator. That is tracking. Okay, this is the circuit representation. We have more or less we need arrangement on the HV side. We need something similar to the salt fog test, except this one is not conducted under fogging conditions. This one will be conducted on a small size of sample about my hand, about this palm, about this one, and then we place it in the here. Okay, we place the sample at the rack, in which we will apply the water drop. In this case, we will allow water to drop flowing over the surface of the sample, where we apply the high voltage at this point, and then the other one is connected to the ground. Connected to the ground, and then this tracking can be equipped with a thermal camera. Why thermal camera? We include the thermal camera to the tracking test, because during the arcing phenomena, there will be a heat dissipation, joule heating, and of course for the discharge activity we should be able to capture the thermal heating on the surface of the insulators. And then we have the transformers. Of course, we want to apply the high voltage transformer to the systems, and then we can actually have the lab view data acquisition, so that all data that during the experiment we can capture and store in a proper drive. Okay, so we have a main control box and over current relay. Okay, this is kind of the safety features that we want to prevent over voltage phenomena or issues related to the flashover. So again, we have the contaminant water. In this case, the other one, we have the salt fog. And for this one, we have the contaminant water. It's no longer fog, but we'll just drop the water contaminant water on the surface of the insulator, so that we should be able to capture or to study by using data acquisition the properties of this sample. Okay, this is the real arrangement. Okay, we have the transformer, see, single transformers. We have the transformers. This is what I call an inclined plane. This is the tracking test, in which water will flow here, and then there will be current flow, and then we will see whether who will survive, that is with the stress or pressure from the constant electrical field stress. So it should be a winning sample to be considered for manufacture. Okay, in this case we have the inclined plane here. Okay, I show you inclined plane here is here, and then we have the extraction fan. Okay, we have the control box. Okay, we have the high voltage resistor, and then high voltage transformers, and then we place the smoke detector for safety. And then this is the interface of the lab view interface. We can design whatever we want, and then this is the control box. Okay. Okay, semua can follow this one, tracking. Okay, tracking. Okay, this is the okay. So again, It is expected for you to know arrangement. What most important is the sample. We connect the sample with the water drop. In this case, it is water drop. Previously, salt fog, we dealing with the fog or light rain or light rain conditions. And for this one, we have the water drop. So we will have water and we have the pump to pump in the water. The rest are just the same. We need to have the measurement or monitoring device. We need to have a transformer, and we need to have a protection device like overcurrent relay. And not to forget that we need to have the shunt resistor, shunt capacitor, to deal with the high voltage. Okay, normally we'll just use a very small rating transformer 415 11 kV to supply the power voltage, and then that one is connected to the again the resistor, shunt resistor, normally 1 mega 1 mega ohm, but it's depend to the expected flow of current, the expected amount of current, the expected magnitude of the current. If we expect the current will be very high, so we need to use a high rating resistor. If we expect the leakage current or the current flow is very low, we can actually use like 10 or 100 kilo ohms. Okay, this tracking test will be conducted as by referring to a British standard, BS, or IEEE standard, in which it will be run or conducted exactly at 6 hours, not more than 6 hours. Okay, because this is not like something that we propose ourselves. The tracking salt fog test, tracking test, these are the tests that been published in the reference, in the what do you call it, in the database of the reference. Okay, so we will run, and then at the end of the experiment, we're going to have a few sample, 6 samples, and then we're going to measure the performance of the tracking, whether which sample that establish tracking distance or severely affected, severely deteriorate, and then that one will be discarded, and that will be further improved by other candidate. Okay, I don't repeat the instruction or the explanation in the text. You can read yourself. Of course, there will be a current flow through the sample, resistive shunt, and then current flow. So I don't repeat this. So again, why we want to perform the tracking test? Actually, tracking test is conducted specifically for insulator, for insulation materials. Just to make sure that the compound for the high voltage resistor, for the high voltage insulator will be acceptable or functioning well. Alright. Next, we're going to have HVAC test. Okay, this is quite straightforward. Okay, straightforward. You can conduct HVAC test to any specimen that you like. Okay, that we want. In this case, we are testing the cross arm tower. Okay, we have the tower, we have the cross arm, and we have the conductor. Okay, how we going to simulate under real working environment is by using a spraying system. Again, when we have a spraying system, we need a tank of water and pump to pump out the water from the nozzle. And then of course we going to have a monitoring system, high voltage AC software, and then in order to monitor, to evaluate the performance of this. Of course, if the test is HVAC, we will apply for the HVAC high voltage. And this one, there will be one connected to the high voltage end, and the other one will be connected to the low voltage or ground. Okay, so pretty much similar to the previous two tests, except this one is a general HVAC test. Okay, a general HVAC test. So as I explained, the volume control artificial rain, we have the artificial rain with the specific conductivity and flow rate. Means that the water, the contaminated water, sample water here is not like a magic values, a magic composition. So we need to be very specific, the conductivity levels, and then the flow rate. We need to set everything to make sure they are on the right track. Okay, working principle, high voltage AC working principle. We've got a sample here. This sample need to be tested with the high voltage and low voltage, and the sample is connected to the monitoring system. Okay, will be connected to the monitoring system so that we can capture the data. Okay. While conducting the experiment, of course, we need to ensure that we have allowed for sufficient clearance. Because what happened when we conduct in the lab, when you inject 50 kV per 50 or 100 kV, the voltage will be very high, and then any nearby structure, say for example we have a metal here, that might trigger a flash over from this terminal to the high voltage terminal. So make sure we applied the right value with the right applications, and ensure we provide sufficient clearance distance so that we can prevent the possibility of flashover and human injury. Okay, now the next is switching and lightning impulse test. Okay, what is switching? What is lightning? What is switching test? What is lightning test? Anyone? Anyone? What is switching? Why we need to perform a switching? Iskandar. Iskandar, why we need to perform a switching high voltage switching test, impulse test? Mana Iskandar? Uzma Afrina, what is the difference between switching and lightning? Semua tak ada ke ni? Ada tak? Nur Razi? Semua mengelat Aliauddin, Ashraf.
Calculated, repeated. Doktor.
Ya, Uzma.
Okay, kalau yang switching untuk boleh can be calculated, repeated.
Macam mana? Again, Uzma. Can you repeat?
To confirm the withstand of the transformer's insulation against the over voltage occurring during switching.
Okay. Thank you for your attempt. And then, okay, saya go on saya tak sure lah at your place. Sini macam hujan nak lebat je. And last few days, we have a reboot here and there, right? So, be careful lah everyone Kalau you kat outside to be careful. Using gadget and etc. Worried of the lightning strike. Okay. Thank you. Thank you Uzma. Uzma Arfina. Thank you. And then okay, for this one, switching and lightning impulse test. Okay, switching, as we know, it is a switching activity, on and off operations. Okay, that is what we call as switching. It's just like you switch on your light in the rooms, you switch on your aircon, and you switch off the aircon. It is exactly the same, except for switching on and off at the house, we just dealing with the 240 volt. Okay, but the switching in high voltage, we are dealing with a 33 kV, 100 kV, 11 kV, kilovolt. So the magnitude is very high, and the implication is also like very important. If you aware, like if you are in the dark, if you switch on the switch at house, you can see the spark. It like you can see the spark, especially in the dark. Okay, you can see. Just imagine that one is 240, and this one switching activity for high voltage is very high, and it will involve a very sensitive safety precautions. Okay, lightning, of course, is a natural phenomena. Natural phenomena. So it is how we going to differentiate between switching and lightning in terms of impulse test. The only way we differentiate them is actually by looking at the waveform, the waveforms. Then only we can tell whether this is the switching, this is or lightning impulse test. Okay. Alright. Okay, switching and lightning. Okay. Switching and lightning impulse test, the circuit arrangement, the circuit representation is almost the same to previously. What we need is just we need a sample here. This is the sample. You can have in this case, it is insulators, and it is a cross arm. We need impulse generator. Okay, high voltage impulse generator connected to the insulator, and the insulator is connected to the ground. And then from here we need some sort of measurement device or monitoring impulse generator. So we need to know the values to evaluate the performance. Okay, so the difference between the AC, high voltage HVAC versus impulse test is just at this point. The circuit. The circuit is the one that will trigger for the impulse waveforms. We have a single stage impulse generator. We have learned in the chapter 2, so I don't repeat. And the purpose is again the same, to test the manufactured product to the limit, to know the limits, and then to ensure that they working fine under certain conditions. Okay, so at least again we need to know how to construct or to have the this test. Okay, and then okay, if we need extra, we can actually put artificial rain. We can place this sample in the fog test. We can do whatever we want, depend on the testing requirement. Okay, is mainly for impulse test. We mainly to investigate whether the manufactured product can work fine or can work well under severe condition, which is flashover and lightning. Okay, and of course we have the monitoring to capture, to save data for post processing procedure. Okay, similar to AC, we need to provide a sufficient clearance so that you don't have the sample very close to any metal structure. We are worried that that might be a flashover from the high voltage terminal inside the gate to the other terminal. That might lead to an injury to the human. Okay, I think we've done up to this point about destructive and non-destructive test procedure. We've learned about a salt fog test, impulse test. We have HVAC impulse AC test, and then we have the, what is the other one? Sorry. Okay, tracking. Okay, tracking test. Okay, make sure in general you need to know what kind of experiment that being categorized under non-destructive or destructive test. What they are used for. What is the purpose of destructive and non-destructive? What are the example of the destructive and non-destructive? And maybe we need to know a bit, a simple illustration. Student don't need to memorize the circuit exactly, but you just need to understand and how we going to. Okay, we have a sample. Okay, the high voltage should be connected at one terminal, and the other one to be connected to the ground, and then the high voltage terminal should be connected to the transformers, etc. You can have on your own. You don't need to follow what been given in the lecture. Okay, you can come up with your own based on your understanding. Okay, since kita is a bit early of the schedules, I think at this point, I think I will just stop at this point. Non-destructive, I will continue next week. Non-destructive, I will just continue next week. Because we are kind of ahead of schedule, so still okay. We've got plenty of time. Because we just got one chapter left, and that chapter is not that much, so it's very okay. It's nothing to worry. Okay, up till this point, do you have any questions about the non-destructive destructive test procedure? You can know this experiment will destroy the sample in general. Normally after one test, we will no longer can use the same sample. That is destructive test procedure.
Hello doctor.
Yes.
Can you hear me? Boleh dengar tak?
Yes, please. Sebab saya tak nampak you all. Saya tengok kat
Tak,
skrin ni je.
Doktor, tak, saya Afi doktor.
Okay.
Saya ada sedikit pertanyaan tentang untuk HbA1c test.
Tak dengar lah, Afif.
Tak dengar sekejap tu.
Slow sangat. Okay. What's the questions?
Ya, sekejap. Hello, tu dengar tak? Dengar tak tu? Clear ke tak? Ke slow juga?
Boleh lah.
Boleh lah.
Saya cuba dengar. Okay.
No problem. Doktor nak tanya dekat HbA1c test. Kalau refer balik dia punya HbA1c test tu, dia usually memang kena pakai cross arm punya tu ke doktor? Cross arm punya
Kena pakai apa?
kena kita punya sampel kita kena kotak dalam bentuk cross arm punya structure ke?
Oh, no. Not necessarily. Okay. Cross arm structure tadi is just example. Okay. You boleh test insulator string. Say for example, you proposal kita buat insulator kan. Kita nak test insulator. What we did is actually, you suspend the insulator, you clip atas, the top one to be the high voltage, bottom one to be the ground. And then, that's it. Just apply the voltage. And then, we should be able to capture whether what is the voltage rating, and we can observe at what point, for example, the voltage, the insulator will fail to operate. Means that at what point the voltage level that will trigger for the flash over. Not necessarily to be in the cross arm punya condition arrangement. Cross arm is one of the example. You can test a sample of the insulator as small as 2 finger size. It depends to applications. Okay, don't get it wrong. It just example.
Okay, faham aku. Nak tanya lagi, HbA1c resonance set tu actually dia kita kena supply ke apa tu untuk testing high voltage?
Okay, mana resonant ni? Okay, resonant. Okay, actually what you need for testing is actually, one is high voltage supply. Okay, once you know how to generate a high voltage, and then you clip at this point, the other point you clip to the ground. That is the most basic configurations for you to apply to perform the high voltage test. You apply. Okay, what are others? What are others is actually safety. Sama juga dengan this one, HbA1c resonance set. It just a matter, it ensure eliminate the probability of the resonance to reduce the resonant effect. This is kind of optional device. Optional device that can be deployed and may not be used. Okay, all you need is actually the high voltage source clip to the sample, and then the other one connected to the ground or low voltage, and then these values will be captured by using software monitoring system. So you should be able to see the fluctuation of the voltage and current. Other than that, if you need to have your sample to be sprayed by to simulate the light rain condition, so obviously you need a nozzle, and with the nozzle you need the tank of water as well as the pump. That is the additional, depend on what test that you are going to perform. If you're going to perform a dry test, we don't need the nozzle and water. If we're going to do the wet test, then we will definitely need to have the nozzle and water supply. Okay,
understood, doctor.
Okay,
so
how
basically kalau based on diagram ni, actually dia just place how the structure, how the method of wet and dry condition, tapi dia tak tunjuk pun untuk kita attach sebenarnya HbA1c supply.
Okay, betul. Macam ni, HV supply dia adalah this one.
Okay.
Okay, HV supply dia adalah this one. Ini dia gunakan dalam bentuk set dia terus. Okay, ni adalah AV supply, dia guna HVAC resonance set. Dia saja guna advance punya lah. Okay, kalau tak, we can actually use this one. Inilah HV supply kita. Okay, HV supply kita is actually a high voltage transformer. That's it. High voltage test transformer. It can be this one, and it can be high voltage resonance set pun okay. Ni kira advance sikit lah. Ini simple punya.
Kalau high voltage resonance set tu kena kena identify lah structure dalam dia macam mana.
High voltage macam mana? Sorry macam mana? Again?
Sebab saya tanya ni sebab ini berkaitan juga dengan kita punya final report project yang bahagian good. High voltage test ni. So yang kita kena, so basically kita kena construct dia punya testing punya setup. So means kita kena, kalau untuk yang doktor kata yang basic punya, kita supply high voltage transformer. Tapi in case kalau kita nak mention high voltage resonance set tu, means kita kena identify juga structure dalam tu, circuit dalam tu.
Okay, it's okay if you want to use at the block diagram, it's okay, acceptable. Make sure you use block diagram. If you want to represent it as a circuit rearrangement, circuit representation, you need to represent it as a circuit representations. Okay, for example this one, okay, we know this is the transformer. They represent as a winding. Winding ni we know that it is a coil winding. So we know it is a transformers. And at some point they use the block diagram. It's just a block diagram, relay, main control. These are the things that we may include in our experiment. For example, why you want to use the overcurrent relay? Okay, so you need to justify. We need to use the overcurrent relay to ensure that this blah blah blah. Why you need to, for example, you think that I want to use the isolation transformer just before. Okay, we want to make sure that if anything happen, nothing to worry on the expensive device, because we want to isolate. If anything happen at this point, that will not affect the device. Okay. So other than that, you can of course like this one, the shunt resistor, we may need to include it as well. To ensure that we should be able to measure the voltage. And for HVAC is actually like this one, you can actually use this one, except for you don't need the contaminant water if you want to perform the under dry conditions, but you definitely need the water tank if you want to perform the test under wet conditions. This is your insulator. Okay, you hang your insulator here, and then one will be connected to the top level, and the ground will be connected to the bottom. So arrangement can be almost similar, except we change a bit, depends on the what kind of test that we going to conduct. Okay. Kalau this one pun, we can actually replace HVAC resonance sets ni with this one. Okay. So it's just the same. Alright.
Alright.
I hope I clarify your concern. Any other questions?
You Dr. clarify. Thank you, Dr.
Alright.
So far, no, I guess.
Okay. Any other questions? Anything you want to ask about your project as well? Of course, you need to develop, to design some sort of the experimental procedure, kan? So you may use this technique. We don't really, and of course, those available in the Googles, in the textbook, you can actually follow them, no problem. But at least we want to know why you want to conduct this test, what is the purpose of each individual test that you plan to conduct. Okay. Any other questions? This is just the sample lah. The sample can be anything lah. In this case, it is cross arm. You can have the insulators. You can have your porcelain insulators. You can have anything that we want to test. Or maybe we how we going to test the transformer oil? How? We want to test the transformer oil. We have a bottle of the transformer oil, and then how we going to test? So we include put the electrode, electrode inside the transformer oil, and then we will inject the high voltage and the low voltage part to the other electrode, and then that's it. So means that we just include the electrode within the insulators, within the oil. From there we can actually measure the performance.
Test the conductivity lah kan, minyak tu.
Yes. Mungkin nak test dia punya yelah reliability, dia punya functionality, whether this one work or not, because people are looking for a new things. Day by day people are searching for new things. For you to propose something new to replace the old one, we need to test, to perform all this kind of tests to make sure they are comparable, they can actually perform exactly to the previous one. After that one is identical, then only we can replace the old one. That is kind of a development procedure jugalah. Okay. Good. Thank you for your questions. A reminder for everybody. Any other questions?
So far tak ada hotel yang lain tak tahu lah.
So far tak ada Okay, kalau dah tak ada, I think we stop at this point. Okay, we stop at this point. We'll continue next week to the non-destructive testing procedure. So in the meantime, if you have any questions about your project proposal and anything, keep me posted or let me or simply ask me. And then about your test, I will announce later. I will try to compose a simple note so that it's become readable to everyone. I think this one is not very heavy. Definitely there will be no calculation on this chapter, except we need to know why we want to conduct the test, the high voltage test. At least how to arrange HVAC test. We need to have the transformers. We have measurements. To be honest with you, as simple as okay, you have sample, you have high voltage transformer, you have a measurement or monitoring, that is absolutely fine. That is okay up to that level. We know how to construct the voltage. The detailed circuit arrangement, I don't really look into that, because what happened is that circuit can actually be changed. The values, the numbers can be changed. The circuit configuration resistor can be parallel, series. That one can always be changed. Okay. So what most important is for you to really know how they are connected. Okay, except for the impulse. Impulse generator, you really need to show the impulse. Okay. Kalau HVAC, simple, straightforward. But for impulse, we need to show that it is as a impulse. This is the detail circuit. Detail circuit. Okay, kalau tak nak detail circuit, you can actually replace with a simple box. Just simply single stage impulse generator. So what is inside the box is actually this circuit. For example, you can draw as a circuit, or you can draw as a block diagram or circuit representations. Okay, ada soalan? Any soalan? Okay, kalau tak ada, I think we stop here. And kita sudahi dengan tasbih kifarah dan suratul as. Subhanakallahumma bihamdika asyhadu an la ilaha illa ant wal as innal insana lafi khusr illa alladhina amanu wa amilus solihat wa tawassaw bil haqq wa tawassaw bis sabr.